Let's talk about lipids. You see some very nice chemical formulas down here, which you might not have seen before, but I would simply like to ask you the following. Which one of these is a triglyceride, which one of these is a phospholipid, and which one of these is a steroid, just using the information over here at the top. A triglyceride is made of one glycerol and 3 fatty acids. And I'm just going to tell you the answer right now. Over here, this one over here is a glycerol part. And that's a fatty acid 1. And the second one, 2, 3. So you see a fatty acid is a long chain of something. The question is, what is this of something? Every corner over here that you see is a carbon. So a fatty acid is a long carbon chain because if I do every corner is always a carbon. Okay, that is the simple way of drawing it. So this is a triglyceride over here. What about a phospholipid? It has 1 glycerol and 2 fatty acids and a phosphate. The phosphate is down here. Do you see this over here? The PO4 group, that's the phosphate. Makes it very polar, even an N over here, which has a positive charge. And the phosphate over here is negatively charged. And over here, we also have 2 fatty acids. Over here, that is 1 fatty acid. And the second one. And this one over here, carbon, carbon, carbon. That's our glycerol. Okay, 3 carbons is glycerol. Also over here, 3 carbons, 1, 2, and 3. And phospholipids are part of the cell membrane. And if you've already watched the video on the cell membrane, and you probably have already seen this little thing over here. It's a phosphate group over here and the 2 tails. And these are the 2 fatty acid tails. And you see that there is a charge over here. This one is negatively charged. This one here is highly positively charged. So the head is very polar, very hydrophilic, very water soluble. While the tails, the phospholipid, the fatty acid tails are not water soluble. So, and a steroid, for example, cholesterol or testosterone or certain hormones, they have a ring structure, and there's 1 ring, 2 rings, 3 rings, and 4 rings. And of course, I do not need to say it. Every corner is a carbon. Okay, again, that's a simple way of drawing it. And that's basically, these are the 3 types of lipids that you have to know. Now, how are the lipids different from each other? Well, of course, the overall structure is quite different of a steroid, but for these two, the glycerol is always the same, but the fatty acids which are attached to it, they can be quite different. And over here, for example, you see a fatty acid with a double bond. Okay, so there's a carbon over here and a carbon here. There's a double bond over here, and over here you have a lot of single bonds. And the one over here, I'm going to erase this to make this a little bit more simpler. The one over here has 1 carbon over here and always 2 hydrogens attached. Except the last one where there's a carbon, and there of course there have to be 3 hydrogens attached. In any case, there is always the maximum number of hydrogens connected, and it is saturated with hydrogens. The maximum number of hydrogens makes it saturated. So this one over here is a saturated fatty acid. While over here, for example, we have a double bond. So there's a carbon over here and a carbon over here. And this means that there is only 1 more bond possible and only 1 hydrogen possible. So we do not have the maximum number of hydrogens because we have a double bond over here, and therefore we're not able to add more hydrogens. So this one is an unsaturated fatty acid. As a matter of fact, because it has only 1 double bond, it's called a monounsaturated fatty acid, this one over here. And while this one down here is a polyunsaturated fatty acid because it has several double bonds over here. So how do you now make a lipid or a triglyceride? Is by taking over here 3 fatty acids and attaching it to 1 glycerol. And every time when I attach a fatty acid to the glycerol, I produce 1 molecule of water. So if you make a triglyceride, you make 3 water molecules. And that is basically, important to know. Yeah? So that is basically the overview of the different types of lipids. Now let's move on over here. I'm going to talk about different types of fatty acids now. I already talked about saturated fatty acids. They do not have double bonds, and they can be found mostly in animal fats. Then there are the unsaturated fatty acids, which contain double bonds. And they can again be subdivided into monounsaturated, polyunsaturated, and also cis and trans-unsaturated fatty acids. And I'm going to explain this right now. So what I'm going to do now is I'm going to draw only a saturated fatty acid without connecting it to glycerol. It's an acid, therefore I have to have a carboxylic acid, a COOH group. Maybe you already remember that this already we had when I talked about amino acids. And then I have a long carbon chain. Well, actually this is quite short right now. I'm just gonna keep it short. And this one over here now has 1, 2, 3, 4, 5, 6 carbons. And everywhere over here I have a CH2, and over here I have a CH3 at the end. And I'm going to now write this a little bit in a short way. There's also a short form of writing this. It doesn't matter if you turn it around or not, but what I have is the following. I have a COOH group over here. Then I have a CH2. That's a CH2. I can repeat this many times. How often do I repeat this? N times. In this case, it's repeated 1, 2, 3, 4 times. And at the end, I have a CH3. So that is basically the CH3 over here. This is the CH2 over here. And this one is the COOH part. And this is basically the short way of writing a saturated fatty acid. Okay? That is basically... that's pretty much it. Okay, that's the simplest form of fatty acid that we have. The unsaturated fatty acids already talked about. They have a double bond. So I'm going to draw an unsaturated one over here. I'm going to write the COOH. Look, this is a short way of writing it. Okay, the COOH is so common that there is even a short way of writing it. I'm going to draw a carbon over here, like this. I have now a double bond. No, this. Where's the mistake? Where's the mistake? Do you see the mistake? How many bonds does this carbon have? 1, 2, 3, 4, 5. That's not possible. Okay, so I do it like this. And let's say I have something like this. It's a very, very short fatty acid. Normally they're much longer. And you can see over here that in this case, the hydrogens are pointing into the same direction upwards. So if this is the case, then we talk about a cis unsaturated. This is the cis isomer. Okay, so that's the cis form, where you have the two H's pointing into the same direction, and the trans unsaturated fatty acids, they look like this. See, and if the H is on the other side, if it looks like this, then it's in the trans. It's the trans, and that's the. I just write this out here. That's the trans form, and that's the cis form. Now, sometimes you draw it differently. I'm just going to show you. I'm just going to draw the thing a little bit differently. If you have a C, sometimes the people draw it like this. H, and then it goes on like this. Okay, the COOH or whatever is over here. Okay, I just want to show you that this basically over here is the trans form, because the H is on opposite sides. It's the same as this one over here. Okay, but it's simply the angles of the bonds are drawn a little different, so it looks quite different, but in reality it's the same as over here. It's also trans. Okay, so that's an example of a monounsaturated, but if there are several bonds in there, several double bonds in there, then you talk about a polyunsaturated fatty acid. So, and simply for the sake of completion, I would like to now illustrate to you how to connect one fatty acid to a glycerol. So I'm going to draw a glycerol molecule over here, carbon, 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 OH, 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 hydrogen, 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 hydrogen. And I'm going to draw now a fatty acid over here, a carbon, OH, double bonded O, and over here I have the carbon chain. Okay, remember, okay? Either with double bonds or single bonds. And look what happens over here. I do the following. This forms water H2O, so it's a dehydration reaction. And this oxygen over here now becomes directly connected to the carbon over here. So I have to actually draw a line all the way across, which is a little difficult to do. So what I'm going to do is I'm simply going to redraw the whole thing down here, already connected. C, O, and then I have the carbon chain. Okay. Okay, so that's already connected, and this one here is not yet connected. So, and this basically happens 1, 2, 3 times, and then you have a triglyceride. Okay, so that's basically explains why you make 3 water molecules when you make a triglyceride, because for every fatty acid that you connect, you make 1 water molecule. So essentially, in these foils, I already summarized quite a lot. I talked about, of course, connecting it to the glycerol. I talked about saturated and monounsaturated fats, fatty acids, about the cis and trans, which is only possible for the unsaturated ones because of the double bond. Yeah, and that's pretty much it. Okay.